with in terms of inserting a needle. Now, a closely related term to fluid rate is this concept of fluid velocity. There is a difference though. What I want you to think about is with fluid, the rate of flow, Q, this is like, if I can use the traffic analogy, how many cars, if we assume all the cars are exactly the same size, how many cars pass by or beneath, let's change that to beneath, overpass X every minute. So imagine, if you will, that we have this overpass. So here's my little overpass. Okay, and here's my road, and we're going to set a camera up. We're going to put a camera on the overpass, and it's going to dangle down, and it's going to take a snapshot. Okay, we're going to monitor traffic, and every time a car passes under that overpass, it's going to take a picture of it. And maybe that overpass or that road is big enough for 3 cars to move at a time, in which case we would be passing 3 cars, and maybe we could pass 6 or 8 or 20 per minute, depending on how fast those cars are moving. Speaking of how fast, velocity is more closely related to miles per hour, or if you're in European countries, kilometers per hour. Kilometers per hour, but it's essentially how fast can something travel per hour, or in this case per minute, because we're dealing with blood. So going back to my figure on the right, if we're asking a question, if our question is how many drops of blood pass through A, so imagine I'm going to set up a camera here. Please forgive my crazy looking camera. So we're going to set up a camera, and that camera is going to take a picture every time a drop of blood passes the landmark. So if my question is how many drops of blood are passing through that cross-sectional area every minute, then what I'm really asking about is Q, my flow rate. On the other hand, let's say I'm going to set up 2 cameras. I have a camera at the starting line, so here's my starting line. And then A is my finish line. And now my question is, how fast does 1 drop move? How long does it take? So how long? And then I'm looking at velocity. And so that's the difference between Q and V. You can see this relationship though, and I want you to know this relationship. My velocity is directly proportional to my flow rate and the size of my cross-sectional area. That makes sense. Go back to the picture above. So let's say every time, let's say I have a freeway and I can move, I have 4 lanes. So here's lane 1 and lane 2 and lane 3 and lane 4. And so maybe my cars are moving, let's say I'm moving fairly quickly, and let's say I have 60 times 4. So 4 through my cross-sectional area. It's a big cross-sectional area. So how many cars is moving through that area per minute? Definitely is proportional to the size of the cross-sectional area, as opposed to maybe, you know, imagine a little overpass that only has room for 1 car at a time. So even if the rate is the same, so let's say my velocity up here is, let's say my cars are moving 20 miles per hour. So even, you know, maybe there's a traffic jam, they're moving slow. Well, because I can move 4 at a time, if my velocity down here is 20 miles per hour, then not surprisingly, in terms of total volume, I'm moving much more blood here at the top one than I am going to be moving here. And so